Yo and what's up? Welcome to my talk on game hacking. I do computer stuff and I also have a blog, and if you want to know more on game hacking and the stuff I'm going to present today, you can also read my blog post, which you can find on this link. That's me, 12 years old, wondering how wall hacks and aimbots and all these cool hacks for Counter-Strike work. And now 1 year later, I've decided to create some hacks myself and present my results. Cheating is actually quite popular in professional Counter-Strike Go gaming, as you can see right here. This guy was caught cheating on a tournament and kicked out immediately. And of course, it's also profitable to create cheats and sell them, and also to use them, because if you win at the tournament, you can get lots of money. Also, I think those techniques I'm going to use for game hacking are quite interesting, because you can transfer them to stuff like malware creating, malware writing, and antivirus evasion. There are a few tools you're going to need. For example, I'm using Visual Studio. I'm creating all my hacks in C++. And you also need a debugger for the games themselves. I use x64 debug. And you also need a reverse engineering tool of choice, for example, Radar, Cutter, Gitra, IDA, whatever you need. And a really handy tool is Cheat Engine. It allows you to scan game memory for known values, and you can basically find all those memory structs and objects using a simple scan of Cheat Engine. There are a few types of game hacks that you can create, one of them being internal, which means you're injecting custom code into a game's process and run inside of that memory segment. And also there's the external hack, which reads and writes memory of another process externally. You can also use something like Frida to instrument your games, but I'm not going to go into that today. The first hack I've created is for a game called Jedi Academy. It's based on the IT Tech 3 engine. People also call it the Quake 3 engine. When you're creating hacks, you need to be aware which game engine is in use. You're going to use a different approach for IT Tech 3 engine based games compared to something like Counter-Strike Go or other games. You need to have a basic understanding of the game architecture and the rough program flow. For example, for the ID Tech 3 engine based game Star Wars, there's the main executable. It's called yamp.exe, and there's a server virtual machine and some client virtual machines. And those virtual machines, they use bytecode to be portable across different devices. That's part of the game engine itself. And the important thing is that they are implemented in own DLLs. And the most important one for game hacking for this engine is the C-game virtual machine. The virtual machines and the main executable, they can call themselves. For example, it's possible that the main executable performs a call inside of the DLL, and of course the DLL can also perform callbacks to the main executable. So for example, if the main executable wants a new frame of the game to be rendered, it calls a function of the C-game virtual machine and delegates the task to this virtual machine. The C-game QVM is implemented in the C-game x86 DLL file, and it has exactly 2 exports which you can list using Radar 2. The DLL entry export and the VM main exports are helpful when creating hacks. So for example, the VM main export is being called by the main executable to perform calls inside of this DLL. And the prototype of it is like this. you specify a command in the form of an integer, and you can pass 12 additional integers as parameters, which is like a generic way to perform calls into this QVM. And the handy thing about this is that this function gets called for things like a new game is being loaded or a new frame is being drawn on the screen, which you can now intercept when you're creating hooks. So for example, if you're creating an aimbot, you want it to perform calculations each frame and check whether the view has to be adjusted to automatically aim at an enemy's head or something like that. And then there's the DLL entry export. It allows the ZGame QVM to perform callbacks into the main process. So for example, if a new player is being added to the screen, or if a player moves on the screen, or new game data is being received from the server, then this QVM will perform callbacks into the main executable. This is the prototype for DLL entry, and one important thing is that it receives a function pointer from the main executable that points back to a function inside of the main executable. So you can use this one to perform callbacks. But more importantly, you get notified in case an entity is added to the screen or it moves, as I already said. So you can manipulate this program flow in order to display an entity on top of walls, which is the main goal of a wall hack. So let's see what happens as soon as the main executable wants to call DLL entry. It loads this DLL inside of its process space, and it calls the Windows API function getProcAddress with the argument DLL entry. This call returns the address of the DLL entry function inside of this DLL, which the main executable can now use to actually perform the call. So the plan is to create a hook in getProcAddress for the main executable and return our own function in case the main executable wants to perform a call for DLL entry. The actual code of the hack has to be injected into the game process. And for that, you can use an easy method like DLL injection, which causes a DLL to be loaded inside of the target process and to be called. For this, you need a loader and a DLL itself. I've created my own loader, which basically follows a standard technique called load library. You open the game's process using its PID and you get a handle to it. You're getting the address of the load library function inside of the kernel 32 DLL and store it in this value. Next, you're allocating memory inside of the target process. You're allocating max path bytes and you make it writable. Next, you're writing to this process memory and you're writing the path to your DLL into it. And lastly, a call to create remote thread is done, which causes the game to call the load library function on the path that's passed to it. So it loads the DLL and it starts at the DLL entry point, and you can verify that it's working by spawning a message box or something like that. Of course, this technique is not very stealthy, so to bypass any anti-cheats, you may do some additional work. For the hooks themselves, you can use a library like mhook, or you can implement this functionality yourself. I've used the mhook library for my project, and it has an API that you can pass the original function address and the function that has to be called instead, and that's it. So now, with the call to getProcAddress being hooked, you can check whether DLL entry is being requested and you can replace the returned address with your own hook DLL entry function, and for all other cases you just call the original getProc address and let it handle the rest. So now with the hook being set up, I wanted to create a wallhack. And I've integrated the official SDK for this game to have all flags and values available that I'm going to use now. And I proceeded to intercept the function that adds entities to the screen. I've created my own function called syscallHook, which gets called instead of the original syscall handling function. And I've created one case where I'm going to execute my own code. And that's the case as soon as the command equals this value. And this tells the game engine that the entity that's in arc0 is going to be added to the screen. And I'm just hijacking this value and I'm adding another engine flag to it. And this flag tells the game to ignore any def information for an entity, which causes it to be rendered on top of the screen for all walls or items or other things. This is what it looks like in action. You can see those enemies through walls, and I've also added some custom shaders for enemies so you can actually see who's an enemy and who's a friend. The other hack I've created is an Aimbot for Counter-Strike Go and for the Linux version of it. You need some tooling for this to make all this game hacking stuff work. You need cheat engine and you need access to the proc maps file of this game so you can see where shared objects are being loaded into. The general plan to create an aimbot is to find your own player inside of the memory and get those coordinates from it so you can actually see where you are on the map. You need to do the same for all enemies, so you need to get those coordinates as well. Then I proceeded to calculate who's the nearest enemy, and then I adjusted the aim to this exact enemy. So now it's required to find the own player inside of the memory of the game. And I knew that there's a shared object, it's called client panorama client, and some functionality is actually directly handled by this shared object instead of the main executable of CSGO. So then in Cheat Engine I've selected this shared object and I've performed some memory scans inside of it. I've searched for known values such as the health of my player, and then I've decreased the player's health by jumping off a ledge or typing in some commands in the console. And then I've performed a new search and I did it all over again, and then you eventually end up with a list of maybe a few addresses that contain the actual health of your player. Now the problem is that as soon as you restart your game, most of those addresses will become invalid since the game will be mapped to a new location in memory and all those shared objects as well. What I did was I added all addresses that contain the health to the address list of Cheat Engine, and I've restarted the game a few times, and some pointers, actually it was only one, remained valid across multiple game restarts. That's what's called a static pointer that you're going to rely on to always find your player structure in memory. If you don't have a static pointer, it will be really difficult for an external hack to do stuff reliably. I did the same for enemies as well. I've created a game with bots and I've typed in some commands so that they are frozen. And then I pushed them up hills and pushed them down, and I performed some scans in Cheat Engine to see increasing and decreasing values. You need to do that all over again, and eventually you'll end up with values that seem to be coordinates, and you can verify it by displaying them on the screen and pushing the enemy and you can then watch the memory changes live and verify that you found the real address of an enemy in memory. For CSGO, there's a structure in memory that contains all enemies in an array, and the object I found on this GIF that I'm showing here is inside of this array. So I can just loop over this array and get all enemy structures in memory. And with that, of course, all coordinates of them. And now you can calculate the 3D distance from you to the nearest enemy. So you take all enemies, perform this calculation, and you check the minimum of this calculation, and then you have the nearest enemy. Now the last remaining thing is to actually calculate the angle you need to look at to automatically aim at an enemy's head. The first thing that's calculated is a delta, which means you're taking your x, y, and z coordinates and you subtract them from the ones of your enemy, which makes you, in this imaginary triangle, the new origin. So next, you know this value and this value. So you know two sides of this triangle and there's one side missing. The next calculation does exactly that. It calculates the remaining side of this triangle. And now it's possible to calculate the two angles you need to look at the enemy. These are those calculations right here. And the third value is always 0 because the game has a 3D coordinate system and a screen only has two, x and y. If you want to know more about this calculation, I have some good references at the end of my talk. I will upload the slides directly after my talk has started. Now that those camera angles are known, there's only one thing missing, and that's actually setting the camera angles programmatically from outside of the game's process. And for this, I've also used Cheat Engine again. There's a command inside CSGO to display all positions and view angles on the screen. So I've enabled this option and I've used Cheat Engine to scan in the memory for those view angles of my current player that are displayed on the screen. And then I froze those addresses. And now I couldn't move the crosshair in the screen. And then I've just unfroze half of my address list and I've checked if I can move the crosshair again. And if you follow this procedure, you end up with one static pointer to an address that contains the view angle, which you can just use inside of the hack. And you write a value to it and the game will just adjust your view to it. And that's a quick demo for the Aimbot. It tries to automatically aim at the enemy's head. And if, of course, it's super unstealthy, it doesn't check whether an enemy is actually seen on the screen or if he's behind a wall. You would need to do some additional work here to make that work, but you can actually use it online. I've tried it. You only get banned because people complain that you're cheating because it's quite obvious, but the anti-cheat didn't detect this external hack. So a few words about detection. Some people say VAC or the Valve anti-cheat that's used for CSGO is a joke because it mainly uses signature-based approaches to detect known cheats, which means that if you're using public code, you're going to get banned, but if you're using your own code, then it's going to be fine, as long as you're hooking functions inside of their middle. So it can detect whether a function gets hooked by checking the first few bytes at the prologue of this function, but if you're going to just hook existing functions in the middle of it, it's very hard to detect it, and currently that's the approach you're going to use. And of course you can also use all those fancy malware techniques like polymorphism or manual mapping, which you're using to implement the Windows API call load library yourself without actually calling load library. So you end up with your DLL being injected into the game, but it's not going to show up in the list of loaded modules. So you can use that to evade some anti-cheats. So that's it. If you have any questions, you can ask in the chat right now. Read my blog posts or all those references I've put on the slide. And don't cheat at LAN parties.
What the hell, man? Cheater!